Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Triple Shockwave from Sun Crossing Rocket. So what do we see here? Well, this is a launch of one of the SpaceX Falcon 9 rockets, and we can see the rocket itself toward the upper left side of this image, and around it we can see the various trails left behind. And that includes the exhaust trail, which is therefore distorting the image of the sun down from the upper left-hand side down toward the lower right. Now, that is an atmospheric effect and does not obviously affect the sun at all. It is only because we have an atmosphere that the rocket is launching through, and it is distorting that light with its turbulence as it passes through the atmosphere. So you can see that turbulence, and it's even much stronger down toward the lower right-hand side where there is significant turbulence in the atmosphere, distorting completely the limb of the sun down toward the lower right-hand side. Now, toward the upper right, we can see something else there, and we can actually see several different shock waves that are present as the craft is traveling through Earth's atmosphere. And those shock waves are visible. They are compressed air from the rocket traveling through Earth's atmosphere and are actually visible in this image as it is designed. Now, to get an image like this, you've got to have everything lined up just right. So you have to know exactly where the sun's going to be and where the rocket is going to be. And that will definitely depend on your location on Earth. If you go further north or south, then you will change the positioning of the rocket relative to the sun. So from most locations, you would not have seen the rocket pass directly in front of the sun, but it would have seen it pass either well above or below it. And that's an effect we call parallax. It's the apparent shifting of a nearby object relative to a more distant one. In this case, the rocket within our atmosphere as compared to the sun about 150 million kilometers away from us. So that vast difference means that the nearer object, the rocket, will shift more as you move around on Earth. Now, the rocket itself was actually taking communication satellites into low Earth orbit, 29 of them, that would then be released into low Earth orbit. And we can also look at the sun. Something else we notice on the sun is that we can see a number of sunspots. Sunspots are darker areas on the surface of the sun caused where the sun's magnetic field has gotten tangled and breaks through the surface. And that extra magnetic field inhibits the flow of energy, keeping that region a little bit cooler. Since it is a little cooler than the rest of the sun, it's going to look darker. It's not dark, it's not cold. It's just maybe 1,500 to 2,000 degrees cooler than the rest of the sun, which makes it look dark by comparison. Quite different than the rocket, which is actually a solid object there in its earlier exhaust that are just blocking out portions of the sunlight. The spots themselves are actually part of the sun. So that was our picture of the day, titled Triple Shockwave from Sun Crossing Rocket. We'll be back again tomorrow for the next picture, previewed to be Rings and Moons. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.